Hey there, math fans. Welcome to Chapter 4, Section 4, using the quadratic formula. So, if you've never used the quadratic formula before, here's what it is in a nutshell. All the other stuff you've learned, the factoring, solved by square rooting, all that other stuff, those are shortcuts that work in only specific scenarios. The quadratic formula is tried and true. It works for every single type of quadratic equation just as long as it's written in standard form, meaning it's equal to 0. Okay? So any type of quadratic equation, you can plug in any of those numbers, you get an answer. Okay, you get a definite answer of what x is going to equal. Alright? So there's a lot of equations out there that are not solvable by factoring or by square rooting. Okay, so you would then have to use the quadratic formula. So it takes a little bit longer. That's why we teach you all those shortcut methods. But yeah, it is tried and true. You will always get the right answer, providing you do it correctly. So before we do any quadratic formula, there's something called the discriminant. It's a derivative of the formula itself, and so that b squared minus 4ac is the discriminant, okay? And you use that to determine the number and type of solution. So here's what I mean. You know that if you take the square root of a positive number, you get a positive answer. And if you take the square root of a negative number, you get an imaginary solution. And then if you take the square root of 0, you just get 0. Okay? So, with that being said, if you take the square root of, if the discriminant is greater than 0, meaning it's a positive number, you're going to get two real solutions guaranteed. Okay? So it'll tell you it'll intercept the x-axis twice, somewhere in there. Could be both positive, could be both negative, but one of each. You'll get two solutions though, okay? Now, if it's equal to 0 exactly, that means you have one solution. Again, the solution itself could be positive or negative, but it's only going to happen once. You're going to just get one answer. And then if you have less than 0, so the same reason why you can't take the square root of a negative number, you get imaginary solutions, you're going to get two imaginary solutions because it's under that square root sign. So you're going to end up square rooting a negative. That's what it's going to say. Now, to do the discriminant, you don't have to take the square root. It's just the stuff that's inside the square root. Do the b squared minus 4ac. And it's either going to be one of these three things. There's no scenario where you can have two imaginary solutions, or sorry, one imaginary solution and one real one. The one doesn't really make any sense. If you only have one real solution, that means it's intersecting there at the vertex. Okay, so it's not going to it's not intersecting twice. There's no second imaginary solution. So if it means it's imaginary, it means it's not touching the x-axis at all. It means it's not touching it at all. So there's no scenario in which it's going to touch it once and then not, and then imaginary in the other one. That doesn't make sense for the type of graph we have. Okay, so let's get into it. Here you have three quadratic equations, and so you're going to use the discriminant to determine the number and type of solutions of that equation. Okay, so the formula once again is b squared minus 4ac. So that means it's helpful to know what your a, b, and c is. So label them if you think that'll help. This is an instructional video, so I think it might help. So I am going to label my a, b, and c. So I have a is 1, b is negative 6, and c is going to be 10. So when I plug it into b squared minus 4ac, I'm going to write negative 6 squared. Make sure you use parentheses, because if you don't, you will get the wrong answer. Minus 4 times a is 1 times c is 10. So you can type it in all like that, but negative 6 squared is 36. 36 minus 4 times 1 times 10 is minus 40, so you're going to get negative 4. So that means, since it's negative, you're going to have two imaginary solutions, or no x-intercept at all. So that's what I'm going to write down below right here. So that's what I wrote right there, two imaginary solutions because the discriminant is less than 0 or because it's negative. Let's look at B. You have A is 3, B is negative 18, and C is 27. You'll notice that all these numbers are divisible by 3, and in other videos we actually factored out the greatest common factor of 3. But again, this is a quadratic formula. You don't really need to do any of that stuff. You can if you want. You'll be using smaller numbers. But yeah, you don't have to do any of that stuff. Just plug it into the formula. So the discriminant here is negative 18 squared minus 4 times A times C. So 4 times 3 times 27. Type that all into your calculator. And you get 0. So what does 0 mean? 0 means you have exactly one solution. So I said it's one real solution because the discriminant is 0. Okay, so remember you have to distinguish a type of solution. So now, last one. 2x squared minus 12x plus 8. Again, these are all divisible by 2. You can divide out the 2 if you want, but you really don't have to. So a equals 2, b equals negative 12, c equals 8. So b squared minus 4ac is going to read negative 12 squared minus 4 times a is 2 times c is 8. So I end up getting 80 for my discriminant, which means I'm going to have two real solutions, and I don't know where they're going to be. I just know they're going to be real solutions because the discriminant is positive or greater than 0. Alright, so now that we've gone over the discriminant, let's actually do some equations where we use the quadratic function, or formula I should say, in its entirety. So looking at this first example, you'll see that it's not in standard form. It needs to equal 0. So the first thing I need to do is minus 5 over to the other side. And again, the biggest common mistake I see as a teacher is people combining things that can't be combined. These are all three separate, non-like terms. I have an x squared that can't combine with the 3x because it doesn't have the power of 2 with it. And the 3x can't combine with the minus 5 because the 5 doesn't have an x with it. So they're all different. Okay? So I have an a of 1 because it's 1x squared if there's nothing there. So a is 1, b is 3, and c is negative 5. So you have this long, convoluted looking formula. You also have the plus or minus thing, which means that's how you're going to get your two answers. I'll go over that when we get there. But just keep this formula handy. You could memorize it. There is a song associated with it, but I will not sing it to you, so don't worry about that. So let's just get back to this. So it says x equals negative b plus or minus the square root of b squared minus the square root of b squared minus 4ac all over 2a. So negative b means flip the sign. So my b was positive. Negative b is now negative 3. So you can't type this all into the calculator. If you did, you'd have to choose just the plus sign, then type it in all over again, and then just the minus sign, because you can't type in plus or negative, the plus and minus sign into the calculator. It doesn't work like that. So I'm going to simplify the top. I'll just simplify everything I can, and I'll write my two answers like that, or then I can type it into a calculator. I'll show you what I mean. Okay, so simplifying the discriminant, you get 29. So it's going to say x equals negative 3 plus or minus the square root of 29 all over 2. Okay, and so you could simplify it from here. Typically, you'll see answers written as negative 3 plus the square root of 29 over 2, comma, and then you'd have it written again, negative 3 minus square root of 29 over 2. So you'll see the x written, your two answers written like that. And then you could type that in individually. So x is approximately the one on the left. is about 1.19, and the one on the right is about negative 4.19. So yeah, sometimes you see it's written in decimal form, but either one of these is acceptable. You would just need to split up the plus and the minus. Pay attention to the fact that there is a plus or minus symbol in this, and so you can't just type all this in at once, okay? Or else you're just probably just typing in the plus sign or the minus sign. You're getting one of these two answers down there, okay? So yeah, that's really all there is to say about that one. Let's do the next one. Here I have 25x squared minus 8x equals 12x minus 4. So, is it in standard form? No, it's not. What can I do about that? I can minus this 12x and add this 4 over to the other side. So the 4 is not a like term to anything, so I'm just going to write a plus 4 over there. So when this stuff cancels, I'm just left with 25x squared minus 8x minus 12x. That means it's going to turn into minus 20x plus 4 equals 0. Okay, so now let's label our A, B, and C. A is 25. Again, you can bypass this step if you feel like you don't need to do it. B is negative 20, and C equals 4. So my quadratic formula is going to say x equals negative b, which is negative 20, so it's going to turn to positive 20, plus or minus the square root of b squared minus 4ac, so that's going to be negative 20 squared minus 4 times a is 25 and c is 4, and all that is over the value of 2a. So I'm going to write divided by 2 times 25. Again, so it might take a little time just plugging in the numbers, but really, that's all you're really doing, just plugging in numbers to a formula. So as a teacher, I notice a lot of students not like this method, and I think that's just because the formula is so long, but just think of it like this, hey, at least you have a formula. So let's simplify this, okay? So the whole discriminant part just makes 0. So when you take the square root of 0, you're just left with 0. So it's really saying 20 plus or minus 0. The square root of 0 is 0 again. Over 50, 2 times 25. So plus or minus 0 doesn't change anything whether you add it or subtract it. So x is going to equal 20 over 50, which of course simplifies to just 2 over 5. So you see how you just get that one answer when the discriminant is 0. And yeah, that's it for that one. So give these next two a go if you're watching this video. Let's pause this video and then I will do them and quickly explain them. Okay, so for this first example here, it wasn't in standard form, so I had a minus 13 over to the other side. And so that gives me an A of negative 1, B is 4, and C is now negative 13. Plugging it all into the quadratic formula gets me this. The discriminant would simplify to negative 36. And so you can't take the square root of a negative, so that means you're going to have imaginary solutions. So the square root of negative 36 is 6i. Alright, plus or minus 6i, but there's already a plus or minus there, see? So just, you wouldn't put it twice. So I have negative 4 plus or minus 6i all over negative 2. The negatives would cancel out here, so here, this is why I have positive 4 over 2. And then everything can be divided by 2, so if you can simplify the fraction, please do. And so that gets me 2 plus or minus 3i. Let's look at the next one. Okay, so here it's not in standard form again, so I minus the 3x and minus 4 over to the other side. 5x and 3x could combine to make 2x. And put your highest degree first, so it should say negative 7x squared plus 2x minus 4 equals 0. So A is negative 7, B is 2, C is negative 4. Plug it into the quadratic formula. So what does the discriminant get? The discriminant is going to get negative 108. Okay, so how can I simplify the square root of negative 108? Well, 36 times 3. 36 is a perfect square. The square root of 36 is 6, and since it's a negative 36, it's plus or minus 6i square root 3. And again, there's already a plus or minus there, see? So now you don't have to remember to write it. So this is going to simplify to negative 2 plus or minus 6i square root of 3 over negative 14. And your negatives would cancel out, and then you can reduce your fraction. So 2 over 14 can reduce to 1 over 7, and 6 over 14 can reduce to 3 over 7. So I can write it like this: x equals plus or 1 plus or minus 3i square root 3 over 7. When you're simplifying something with a radical, don't touch the number on the inside, only touch the number on the outside, okay? Other than that, that's it for the notes. If you're one of my students, go ahead and please take this exit quiz now. If you're not one of my students, feel free to take the exit quiz if you want, but you won't get any feedback for it. Okay, bye everyone. Thanks for watching.